For decades, astronomers have suspected that something is hiding in the outer part of our solar system. Far beyond Neptune, where the Sun looks like a tiny point of light, a new, unknown planet might be orbiting. This mysterious world is called Planet 9, and it could explain why some distant objects in the Kuiper Belt move in strange and unexpected ways. But here's the strange part. Even with our most powerful modern telescopes, no one has ever seen this planet directly. It's almost as if something big is out there, but it refuses to reveal itself. So why do scientists still believe in it? Because many clues point to a massive object pulling on smaller worlds far beyond Neptune. Some of these icy bodies seem to follow orbits that line up in the same direction, almost like they're being guided by an invisible force. And according to many experts, that force could only come from a large, unseen planet. For years, this idea remained a theory, an interesting possibility but not a confirmed discovery. The outer solar system is simply too dark, too far, and too slow-moving for normal telescopes to catch anything clearly. But now, something has changed. A new study has re-examined data from two old space missions, one launched in 1983 and another in 2006. These missions scanned the sky in infrared light, which can detect the heat of cold, distant objects that are almost impossible to see in visible light. When scientists compared these two missions, separated by more than 20 years, they found something surprising, a very faint object that appears to have moved just a little between the two observations. And that tiny shift is exactly what a slow-moving, faraway planet should look like. It might be nothing, it might be everything. But one thing is certain, the hunt for Planet 9 has just received its most exciting clue in decades. Now, let's explore why scientists believe in Planet 9 in the first place, and what the strange motions of distant icy worlds are really telling us. To understand why Planet 9 became such a big idea, we have to look at the strange behavior of objects far beyond Neptune. These icy worlds, called trans-Neptunian objects, or TNOs, include famous names like Sedna and 2012 EP113. They orbit the Sun at extreme distances, much farther than Pluto. Now here's the mystery. Many of these distant objects have orbits that point in almost the same direction. This is not normal. In a balanced solar system, we expect distant objects to be scattered randomly, each following its own path. But instead, several TNOs seem to be clumped together in space. Their orbits tilt the same way, and their closest approach to the Sun happens in similar zones. If this happened once or twice, it could be chance, but the more scientists looked, the more patterns they found. In 2016, two astronomers, Konstantin Batygin and Mike Brown from Caltech, decided to study this mystery in detail. They ran thousands of computer simulations to test different explanations. After checking every possibility, from passing stars to random coincidence, one answer fit the puzzle better than all the rest: a hidden planet. Their calculations suggested that a planet 5 to 10 times heavier than Earth could be orbiting the Sun at a huge distance, somewhere between 400 and 800 astronomical units. Remember, 1 astronomical unit, or AU, is the distance from the Earth to the Sun. If such a planet exists, its gravity would act like a giant shepherd, slowly pulling distant objects into stable positions over millions of years. That would explain why so many TNOs line up in the same direction. It would even explain why some objects have extremely stretched out orbits, almost like they were kicked outward by something big. In simple words, the orbits of these distant objects look like they are being influenced by an unseen world. This was exciting, but also frustrating, because even if the planet is out there, it is incredibly hard to detect. It reflects almost no sunlight. It moves extremely slowly, and the region where it might be hiding is huge. Still, the evidence kept building. More TNOs were discovered with the same strange pattern. Many astronomers began to take Planet 9 very seriously, but this raised a big question. If the signs are so strong, why can't we find the planet itself? The answer lies in the extreme darkness of the outer solar system, and why normal telescopes are simply not enough. That's where infrared missions come in, and where the story gets even more interesting. If Planet 9 is really out there, why haven't we seen it yet? We have giant telescopes on Earth, and even the powerful James Webb Space Telescope in space. So how can a whole planet stay invisible? The answer is simple: distance and darkness. Planet 9, if it exists, is extremely far from the Sun. At a distance of 400 to 800 AU, it receives only 0.1% of the sunlight that Earth gets. That means it barely reflects any light back to us. In visible light, it would look almost like a cold black rock floating in empty space. But there's a second problem. It moves incredibly slowly. Most planets shift their position in the sky every night, but a planet hundreds of AU away might take thousands of years to complete one orbit. Its motion across the sky is so slow that in a normal telescope survey, which lasts only minutes or hours, the planet wouldn't appear to move at all. It would look like just another background dot. So we have two major challenges: too little sunlight to reflect, too little movement to notice. This is why even modern telescopes struggle to find Planet 9. But astronomers came up with a clever idea. Instead of trying to see the planet in visible light, why not search for its heat? Even a cold, distant planet still gives off a bit of thermal radiation. It's faint, but infrared telescopes can detect it if we know where to look. This brings us to two important space missions. One, IRAS, Infrared Astronomical Satellite, the first ever space telescope to scan the entire sky in infrared. AKARI, 2006. A Japanese infrared mission with better sensitivity and more advanced instruments. These two missions didn't search for Planet 9 directly, but they captured thousands of faint infrared sources across the whole sky. And here's the smart part. Because the two missions are more than 20 years apart, scientists can compare the data and look for tiny movements. Even a very slow-moving object would shift slightly in that time. In simple words, one mission gives a snapshot, two missions give a motion. But finding that motion isn't easy. The sky is full of infrared signals, from stars, dust, galaxies, and noise. Scientists needed to filter and analyze these signals carefully, and that is when something interesting appeared. One faint object seemed to show the kind of slow, gentle drift you would expect from something far away, possibly even a distant planet. Was it a mistake, a glitch, a known object, or something new? No one knew yet, but this faint moving signal was strong enough to push astronomers to take a closer look. Now, let's explore what the researchers actually found, and why this tiny shift might be the biggest clue to Planet 9 so far. When scientists decided to recheck the old infrared data from IRAS and AKARI, they didn't expect much. These missions weren't designed to hunt for planets. Their job was simply to map the sky and heat signatures, picking up everything from warm dust clouds to distant galaxies. But a team led by astronomer Terry Longfan at National Tsinghua University in Taiwan believed there was something more hidden in the old data. They designed a careful search method. Study how bright Planet 9 should look in infrared, predict how slowly it should move over 20 years, scan thousands of infrared sources and filter out everything that didn't match. This process wasn't quick, it wasn't easy, and at first most signals turned out to be noise, stars, galaxies, or objects already known. But then, something stood out. A faint object appeared in both missions, 23 years apart. It was dim but bright enough to match the expected heat of a distant cold planet. It showed a tiny movement, just a small shift, but exactly what you'd expect from something extremely far away. And strangely, it didn't appear during certain times, when it should have been visible if it were a closer object. That meant the object was not nearby, not fast-moving, and not a typical asteroid. In simple words, it behaved exactly like a slow-moving, distant object that could be Planet 9. What could this mysterious infrared source be? At this stage, scientists cannot say for sure. There are a few possibilities. One, it could be Planet 9, a planet 5 to 10 times heavier than Earth, still glowing faintly from leftover heat. Two, it could be a large trans-Neptunian object, something bigger than Pluto but not planet-sized. Three, it might be a brown dwarf, a failed star that's too small to shine but still warm enough to show in infrared. Four, it could even be a rogue planet, a world formed around another star, drifting through the galaxy. and later captured by our Sun. All of these are rare. All of these would be fascinating, but only one of them would rewrite our maps of the solar system. To confirm what this object truly is, scientists proposed a follow-up investigation using the Dark Energy Camera, DCAM, in Chile. This instrument is incredibly sensitive and can scan a very large part of the sky at once. DCAM is basically the perfect tool for detecting slow-moving objects at the edge of the solar system. If DCAM can redetect this faint source and confirm its motion, the mystery may finally be solved. But just when the Planet 9 theory seemed stronger than ever, something unexpected happened. A new discovery, a small icy world far beyond Neptune, challenged the Planet 9 theory in a surprising way, and this twist complicates everything. As excitement was building around the faint infrared signal, astronomers made another discovery, one that added fresh doubt to the Planet 9 theory. A team studying the far outer solar system identified a new dwarf planet called 2017 OFF 201. It isn't very large, only about 700 kilometers wide, similar to some of the known objects in the Kuiper Belt. But its orbit is what truly surprised scientists. This tiny world follows an extremely stretched and unusual path around the Sun. At its closest, it comes into about 44 astronomical units. At its farthest, it swings out more than 1600 AU into the darkness. One full orbit takes roughly 25,000 years. For almost all that time, it sits so far away that no telescope can detect it. We only spotted it because it briefly passed through a part of the sky where our instruments had a chance to catch it. But this is where things become interesting and troubling. Many distant, icy objects orbit in directions that line up with each other. This strange alignment is one of the main reasons scientists believe Planet 9 may exist. Its gravity could be nudging those objects into similar paths over millions of years. But 2017 OFF 201 doesn't follow that pattern at all. Its orbit points in a completely different direction, around 306 degrees, far from the typical cluster near 60 degrees. For researchers, this was a serious issue. If Planet 9 were controlling those distant orbits like a kind of gravitational shepherd, then new objects should follow the same alignment. But this dwarf planet ignores the rule entirely. The story gets even more dramatic when simulations come into play. Scientists ran computer models to see whether 2017 OFF 201 could remain in its unusual orbit if Planet 9 existed as predicted. The results were surprising. Without Planet 9, the dwarf planet's orbit remains stable for about 1 billion years. But when Planet 9 is added to the model, the orbit becomes unstable. Over roughly 100,000 years, the dwarf planet would drift too close to Neptune and eventually be thrown out of the solar system altogether. This leaves scientists with two possibilities. Either Planet 9 doesn't exist, at least not in the form or location we currently imagine, or it does exist, but its orbit and position must be very different from the predictions made so far. This discovery doesn't kill the Planet 9 idea, but it certainly makes the picture more complicated. So, does Planet 9 exist or not? Right now, we simply don't know. We have strong gravitational clues. We have a faint infrared signal that might be meaningful. We have a new dwarf planet that refuses to follow the expected pattern. And we still have an enormous amount of sky left to explore. Planet 9 could be a super-Earth, a giant icy world, a rogue planet captured long ago, or something completely unexpected. Or it might not exist at all. But here's what we do know. The outer solar system is still full of secrets. We've mapped only a tiny fraction of it. Thousands of distant objects are still waiting to be found. And every new discovery changes our understanding of our cosmic home. Somewhere far beyond Neptune, in the freezing darkness, something may be waiting. Maybe it's Planet 9. Maybe it's another kind of world. Or maybe the mystery lies in the shadows themselves. But until we explore the deep edges of our solar system with better tools and deeper searches, the question will remain open, pulling us forward, just like gravity